Okay, thanks a lot for the intro and the warm welcome and the warm pizza. My name's Dan. Before I get started, I just wanted to gauge, because this is my first time here at this Cloud Native Vancouver, so thanks for welcoming me here. Before I get started, who's ever heard of Ceph before? Okay. Who's ever heard of Rook? Is it different? It's the same people? Less people? Okay. Well, okay, so I'm going to talk about Ceph and Rook. And I'm a CTO at a company called CLYSO. It's a company that's been a kind of open source cloud modern IT solutions for about 15 years. And 3 years ago, we expanded to North America. And last year, we opened an office here in Vancouver. I'm a Vancouver native, and my name's Dan. So who knows what that thing is?
CERN.
Yeah.
LHC.
The LHC?
Doomsday machine.
Yeah. Oh yeah, totally.
Yeah.
So that's the largest particle accelerator in the world, in Geneva, Switzerland. That's a 27-kilometer ring. It's 100 meters underground. There's like an airport there, and somewhere around down here, there's a tank of hydrogen that like opens up, and then it progressively gets accelerated into these clouds, and then you smash particles together to discover the fundamental nature of the universe. Okay, that's where I lived for 15 years. Okay, so that's CERN is that little thing there. That's Crozet, France. I'll be there next week, actually. That's gonna be fun. But yeah, this is what it looks like underground, 100 meters underground. That's called a solenoid magnet. It uses 10,000 amps to squeeze and accelerate clouds of protons in opposing directions. There's like 2 tubes there. And then at 4 different corners of that circle, they like kick those little clouds of protons into each other and smash them into each other. They get accelerated up to the speed of light minus 11 kilometers per hour. Okay, that's how I like to say it, instead of saying like 99.999, because who knows nines? It's not an intuitive thing. Yeah, most of the time when you have like one cloud of things going through another cloud, they kind of just pass right through, right? And maybe sometimes like a few of them glance off each other, but sometimes they do like a head-on collision. I can see some of your expressions are like, what does this have to do with Cloud Native? You'll understand. This is what one of those, like at those places where they're smashing them together, this is what, they have cameras, okay? One of those cameras is called Atlas. So are people familiar with this? Has anybody ever heard of Atlas? A few of you. Anybody worked in this stuff before? Okay. So that's one of the cameras. There's a person in that picture. You can't really tell, but around the L's, that's his feet, okay? This is a thing, it's building sized. It's basically just a digital camera that's sensitive to more than photons. It's sensitive to the muons that are passing through us. Did you know every second there's a cosmic ray passing through your body? And then it continues passing right through the Earth and goes to the other side and just continues on its journey. You can make I think at UBC they probably have a cloud chamber. You can see this in real life. You can make one too if you want. Anyway, that's one of the cameras. Oh yeah, that's me. Yeah. Yeah. So I went there. Like I went to UVic. I did a PhD in distributed computing for the Grid Canada back then in 2008. At some point, someone said, "Hey, maybe you want to go try and work at CERN for a year. It'll be really fun, and then you can come back." So that's me that year. That was 2008. Isn't that weird? Yeah. Okay.
UBC Triumph works on Atlas.
Absolutely. UBC Triumph is a tier 1 of that.
Yeah,
so
yeah.
This is what the pictures look like that thing takes. And that thing, that's a Higgs boson. Anybody heard of a Higgs boson before? The God particle?
Doomsday particle.
Yeah, that's just the fundamental particle. That completed the standard model of particle physics. Now we know what it is that gives things mass, why we weigh something, why when we push against something, there's something that pushes back. Like, it's because of this guy. And we found it. In 2012, we found it, and in 2013, we got a Nobel Prize for that. So that's a picture of one of them. It's just a thing. Yeah. To detect a thing like that, it takes a heck of a lot of computers and a heck of a lot of storage, a heck of a lot of clouds, okay? This is what that thing that ended up being a Nobel Prize and solved a great human mystery and was a kind of magical thing. This is the research paper that thing was, observation of a new particle, blah, blah, blah. And it's like, do you see that bump? Like, that's it. That's the discovery. And that required like tens to hundreds of petabytes of data per year to generate that bump. That's what the whole purpose of this giant machine, the most largest machine in the world, the LHC, is all about. And that's how I got into, this is our data center at CERN. Okay, it's a big thing. That's one of them. There's 2 floors. That's half of one of the floors. It's fun. It has a kind of hot aisle, cool aisle thing going on, and that's how I got into storage. So when I first went there, I was working on distributed computing, scheduling researchers' jobs across supercomputers around the world, and then I got into storage, okay? And in 2013, we were doing this kind of science, and we were trying to have to build a cloud. Cloud computing became the big thing, and this is what I got into. So this is what the requirements for doing all of that science. Now I segue to like the real topic of the talk, right? For building and supporting a big research lab like this, like you need something like what you get from AWS. In the end, like all IT stacks around this time started modernizing. Who's used or heard of OpenStack? Okay, yeah. Who's more familiar with OpenStack than Kubernetes? Like, everybody's Kubernetes now? Yeah. Okay, so this is what it looked like. I mean, we were building a cloud back then. And as it usually happens in most organizations like this, someone buys a lot of CPUs, and then like they remember that they should have bought some storage, and they knock on one poor guy's office like, hey, can you help us? Like, we gotta do some storage. And they don't wanna go spend like millions at NetApp or something like that. You gotta do something with open source. They're hoping you can just download something for free and suddenly get tens of petabytes, download more RAM, right? This is what the requirements look like. You wanna be able to do multi-protocol, so POSIX, object, and block. You want to use commodity hardware because hardware RAID sucks. You want no fixing.
Dell servers or what?
Commodity hardware, it means like super micro motherboards with no label boxes, JBODs. Okay, Quantum's another one. E4s, lots of these guys, Boston. You just buy like the cheapest stuff before anybody puts a label on it and charges a warranty. Yeah, horizontal scalability. You want to be able to, you can't plan what anybody's going to be doing. You want to be able to scale horizontally, just add more performance or capacity. And you want something that's mature. And you want to be able to handle multiple data centers, scale globally. This is in 2013, then this was me and my friend in the office beside where the World Wide Web was invented. There at CERN, like the way it works there at CERN is you're like, okay, let's do a proposal. You got to do a memo. We need to have 1 petabyte usable. This was what it was like. I had a pretty lucky job here, obviously. And around that time, I subscribed to the mailing list of this thing called Ceph users. So now we know, like, we're linking into the Ceph project. This is what Ceph is. Ceph is a unified storage system, distributed storage. It's actually like a low-level object store called Rados, a reliable, autonomic, distributed object store. That thing's like a key value. It's like sort of like Memcached or something like that, but it's all persisted and it's like super, super reliable. You can do replication, you can do erasure coding, you can do all kinds of things like that, but most people use it through one of these 3 applications servers that are built on top of it. There's the RGW, which does object, which is S3 compatible object, or for those that remember OpenStack, it's Swift. It's also Swift compatible object storage. It's also block storage, so it's like it's your iSCSI, but it's a modern version of iSCSI. And it does CephFS, which is a file system. That's like NFS. It does all these things out of one system. But like, what is it? Like, yeah. I don't know. This is funny. When you type Ceph, sometimes you get this one popping up, especially when your geo is in Vancouver. Apparently, there's an octopus in the aquarium, or there was, named Ceph Rogan, but that's not what we're talking about here, right? Yeah. I keep saying all these like buzzwords about like Ceph, like it's software-defined storage. Like, what does that mean? It's unified storage. It's the future of storage. We used to, back in the early days of this project, they hired there was a startup involved in it then, and there was a marketing company that said, call it the future of storage. And they still have t-shirts with that name. It's like, how about like, it's also now. Yeah. But anyway, what it is it's open source software. It's software that you can download. It's like Apache. It's like Kubernetes. And it runs on that commodity hardware like I was talking about. So this is matching those requirements that I was mentioning earlier. Works on IP networks. It supports any kinds of devices, spinning disks. It also supports tape now even, and it's all in one. It's free and open. It's built for Cloud Native and all that stuff that we love so much. It's a very mature piece of software now, software solution. It's used, I didn't really introduce myself. Okay, I guess I did, but I forgot to mention I'm also like by now co-chair of the Ceph open source project as well. So in our public telemetry, where we have the users reporting back, there's more than 2 exabytes there across over 4,000 clusters. But we know there's a lot of private usage of this, more than 10x this. Lots of the hyperscalers are using it, and for sure all the like mid-tier cloud providers that we use are using Ceph. Actually, it was invented by Sage Weil, who is one of the founders of DreamHost. So it was invented for DreamHost to be their backend storage. It powers. I don't know. I might even have a plot. Yeah, in the public surveys that are done, it's like over 90% of all the open infrastructure clouds are using it, and it's harder to get that kind of statistics for Kubernetes, but it's pretty much up there. And it's super high performance. It can be. It's not targeting performance as its thing, but certainly you can get it. We have done demos in our company up to over 1 terabyte per second and 25 million IOPS. Yeah, it just depends on your hardware. It scales horizontally, so you just got to like throw more hardware at it if you want.
What kind of interconnect transmits a terabit per second?
So Ethernet.
Terabyte? Yeah.
Ethernet. I guess that's a Petabyte. Does anybody actually say Petabyte? I don't. All right. Who cares about the metric system? All right. This is the history of that project going back to 2014. This is a bit of detail for people when I'm just introducing to Ceph for the first time, but there's a lot of, for those of us that have been using it for a while, it was some kind of like, it was a very, very active like open source community. We had lots of events during when OpenStack was big in like 2010s and all of that. I don't know, did anybody go to the OpenStack conferences that were here in Vancouver? Yeah, these were 10,000 people here coming to talk about this kind of stuff, to talk about Ceph and OpenStack. And it's all about open source versions of AWS, S3, and EC2, and all the other rest of the stack. Yeah, it's kind of like gone down now, but it's still used everywhere. This is just a story of us adding various features along the way, and it's still like maintained quite actively. The main stakeholder in the Ceph project is IBM, because Ceph started out as a research project. It turned into a startup that got acquired by Red Hat, and then Red Hat got acquired by IBM. So IBM's investing a lot into the Ceph project and related stuff now. Maybe 400 developers, but CLYSO us, we have something like 50 people working on it, and we're doing our best. How is Ceph different from any other storage system? So if you've like built apps and storage before, like this is the somehow traditional way that storage works. You'll have like a server, and actually I'm kind of like, one of the things about all cloud native stuff is it sort of still does this thing, and I'm not that happy about it. But you have like a virtual IP and you have backup stuff, and you just like fail over, and you move IP addresses around. You try to have one common backend with gateway nodes and things like that. So Ceph's not like that. Ceph moves some intelligence into the client side, and that kind of intelligence is like, it's basically some fancy algorithms so that the clients can very quickly compute where the data that they need is, without having to like index into some kind of remote database server or something. They just know. You can just calculate it based on the name of the object. When you're building one of these clusters, there's lots of different components, but it's like mostly just disks, and then there's a few metadata servers and index things, like, but it's a very simple and extendable thing. If anybody remembers from their comp sci days, like there's this like, are you familiar with CAP theorem? Who's heard of that? Yeah. When you're building a distributed system, you have to make some choices. you have to choose, basically, it's one of these trilemmas. You have to choose between consistency, availability, and partition tolerance, and you can only pick two. Okay, so, and then whichever two that you pick, that influences strongly like what kind of system that you're gonna have, what kind of data system. So Ceph fits into the CP type systems. And what that means, like in practice, they're basically, it is kind of weird. The idea of like AP systems, I think they're kind of weird. But a CP system means that like the storage server or the application will never ever serve you some data that might be wrong or might not be the latest. There's no like, clients are not allowed to cache things unless they're explicitly allowed some kind of like lock to cache a thing. Yeah, so, and what you really compromise therefore is availability, because it means that like, availability means like, okay, we'll keep this website up, but it might not be the latest version of the website. Ceph is a CP system, it's different. You can of course build CA systems on top of it, but it's open source. I just like felt like making this one. I love thinking about this one. Who works in open source stuff? Like, I mean, this is a cloud native thing, but anybody work on open source software? Like, yeah. I made this slide before I was speaking at SFU, and it's like, people don't really understand what open source is, so I kind of like, this is a nice famous XKCD. Who's seen this one before? Yeah. It's like everything, all modern digital infrastructure, like, yeah, of course, like when CDN goes down, it's like here. But it's actually just like some random person that's been like maintaining some library, libgzip or whatever, who cares, right? But I use our AI overlords to edit this and be like, it's like there's people. When I try to make the analogy to like how can you explain it to your grandma, like what do we do? It's like, imagine you're driving on the roads and like underneath the concrete, there's a bunch of people holding the road up. Like that's literally what we're doing in the open source world. So yeah. Who uses it? Okay, this was more about that. Like, it's like kind of everyone. There's all these different proprietary storage providers, and because I work now in enterprise and supporting lots of different companies, it's always the same story. They'll get a discount on some proprietary thing. It's like amazing. It's cheaper than anything else. And then like in 5 years, when it comes time to replace, it's like 3 times the price, and then they have to migrate the data. So you can see lots of other proprietary things like little 5-year bumps of like when they were popular. But Ceph just like went up and up and up and up over the time. There's a lot of logos of different. These are companies that have spoken at our events. So we organize Ceph events, Ceph days, Ceph conferences. The bag that we've brought you guys a swag bag because we're pretty proud of this logo. We commissioned this from a Musqueam artist here in Vancouver. This is the dual-headed serpent of the Musqueam tribe, and it's said to have, it goes over by UBC in the what's that park, Pacific Rim Park, is that what it's called? That's the Musqueam land, traditional lands, and like this dual-headed serpent like went around there and laid the droppings to plant all the plants there. And also it's like the children's like, don't go in there because this thing's gonna eat you. Like that's the kind of thing, but that's what this is. And also like the octopus in the middle, like Ceph is because of cephalopods, which are like octopuses and squids, and they have this like distributed intelligence throughout their bodies. That's how this is all named. That's what all this logo is. Anyway, our logo's not on there, but these are some of the companies and things using Ceph. How does it work? A bit of a nerding out here, if people are interested. And keep me honest on time, Reza. Yeah? I'm good?
I'm ready to hear.
Yeah?
Let me know more of the details.
Okay. So we'll do this, yeah. This is like how it actually works. This is earlier that distributed intelligence thing I was mentioning. The question when you're building a storage system is like, okay, you have some file, maybe like an MPEG or whatever, MP3, anybody want to remember those? You split it into objects, and then you like store those into some pool. It's like a whole virtual concept, but like, it's like, what does it do? Like old school systems would use like an index, which is like a database basically. It's just like, oh, I'm gonna record, it goes here, it went onto that server. That's even more or less how Amazon does it. Ceph uses something called placement groups, and it actually just calculates which of the like this object or goes into this pool, and then these parts of this pool get put like randomly into one of these things according to like a consistent hashing algorithm. So simplest consistent hashing algorithm would be like, let's do the MD5 sum of the file name, and then just like do modular arithmetic, something like that. But that's like a very dumb way to do it. There's many PhDs worth of science into doing that smartly. And that's where it does. So it's just like calculating where the data should be put. And that somehow, there's a lot of pictures here. It's very hard to explain this in 30 seconds, right? But you can trust me that like the file ends up onto like eventually, let's say 3 different disks. So if one of them fails, it's on 2 more and it like automatically heals itself, okay? And there's a lot more to it and it's a very fun, very impressive thing. When I learned about it in 2013, I was like, huh, yeah, this is like correct. It's like the way to do it. And it's like now I'm still 2026, still working on this, talking about it here in my home of Vancouver. Yeah. There's a bit like because I have like a more of a scientific background, I really like super nerding out about it. And you see how like when I talked about the LHC is like speed of light minus whatever, it's like, it's also like, you know, when we who here uses the cloud? Like what a question that is. Yeah, I hope yeah, everyone, rhetorical question. But like when they talk about things like data durability and data availability, and like, I don't know, personally, I don't find it very intuitive the way that they talk about it, all these percents and stuff like that. So like, what does it actually mean? So this is 11 nines. What it means, this is real. This is the Amazon S3 SLA. Like, it means that on average, if you're storing 10 petabytes there, okay, I put the number as if you're a scientific user, right? I mean, I don't know if my Plex server is 10 petabytes yet, but probably not. But you're gonna lose 100 kilobytes of data per year on an average year. Maybe that's averaged over 1 million years, but that's your expectation. And that's a way to think about it. But then availability is, of course, a much more realistic thing to look at. It's much more tangible. And availability is like, they quote like 99.99, so 4 nines of availability. And that means like you should expect 52.6 minutes of downtime per year. Is that making sense to people? That's their expectation. Who here is like a SRE? Who's like done like Google SRE stuff? Yeah, when I did that, the most compelling thing in the whole book was like, spend your downtime budget. So you guys remember that? So this means if the service is like 4 nines, and if you make a service and you're telling your customers it's 4 nines of availability, you better make sure your service is down for 52 minutes a year. Otherwise, they're going to build up an unreasonable expectation dependency on your service. Yeah, and that's real. That's like how I burned out at CERN for 1 year, a little bit, because you have these reliable services, and then they're like, whoa, they're just it's like everything goes on it. The pension fund goes on that one for sure, and then suddenly it's down one day because reality happens. But anyway, so I had fun, like there's a lot of fun that we do at our company with this. We support enterprise clients with this, and we work in the open source side, but we also have fun trying to understand how it works. So with I didn't go into too much detail at all about how that bump in the plot actually represented the Higgs boson. But like it's related to how we have a Ceph simulator as well. We simulate our storage as well, just to understand how to make a more reliable storage system. The basic thing, if I could say it quickly, is this: like you build a system that simulates how it works according to what the theory is, and that's something we call Monte Carlo simulations, right? And we have a simulator thing, and then let's just randomly fail some disks sometimes, and then see, are we still able to access the data? Like that's what this thing does. In the particle physics world, you simulate according to what we know that the laws of physics are, and then we do experiments in real life, and we see if there's a difference between like the simulation and real life. And like the more and more simulations, like 200 supercomputers around the world, is to make it so that you have a very accurate simulation, and then like more and more data of real colliding all those particles makes like very accurate like real life. And then, okay, wow, they're 6 sigma apart. That means we've discovered new science. That's what that's about. Anyway, there's a simulator. We do this. So if anybody, I'll show you how to download Ceph as well. But also, like, if you want to like play with this stuff, if you're interested in the math behind it, this is something fun. And this is also the first time I get to plug our GitHub, so you can see there, CLYSO.com, and we have lots of different tools and fun stuff in there if you're getting into this topic. This is a graphical thing. I bet you guys can't guess which utility we use to make this one, but this is that same CLI simulator in a nice, amazing graphical form that we have that we will have up on our website soon. But this is just an example of the kind of stuff we do. Let's see if that works. Yay! But if you want to use it for your Cloud Native and for your Kubernetes stuff at work, like there's a project called Rook. Rook is Ceph. It's the same thing. They're one in one. So we already know what Ceph is, and Rook is like a Kubernetes operator for Ceph. It's just, you know, being like me or being like us that runs Ceph in the Kubernetes world. Oh, why does it switch to that? There's no way to auto loop in Google Meet, but so it's yeah, it's like you can plug it in and have like a hyper-converged system that's like your compute and your storage all in one. It does all your PVC storage classes and stuff. Because it's Ceph, it's auto-healing, but then also it does all of the like Rook itself then does all of the like crazy shit. Like Ceph is a very complex, very flexible but complex piece of software with lots of moving parts. In the home lab setting, yeah, you could do it with one server or 3 servers. In a company, you probably just want like 4 servers minimum to start with it. But then like universities or larger organizations, it gets to be tens or hundreds of thousands of components, but Rook takes care of all of that for you. And yeah, like I said, it's hyper-converged. I'll show that video once more because that's it. Like if you want to do it, you gotta memorize that right now. So just, I guess you'll have to download something before you do that, but you can, it's just to like create the operators, right? And then it'll create the cluster, and then you just kind of like, wait a second. By the time you get the command typed out, it's like already started the services. So those are the core services of a Ceph cluster. And with that, you now have like, you can create PVCs in your Kubernetes. If you just want to try it outside of the context of, outside of the Kubernetes context, the project itself, we just have an installer. It's called Ceph ADM. That stuff from the video before, just go to rook.io. You can just download and try it out. It's lots of docs. We have a Slack. There's docs on both the sides. And like I said, we organize events. So we don't have another one in Vancouver planned, but probably early next year, I would say. I have 2 colleagues in the back there. If you raise your hands, Rushali and Josh, they work here in the company, and they're here with me today. So they will participate. And yeah, so there's lots there. You can take a look. Because I like seeing the science impact of this stuff. Like, who's heard of the Rubin Observatory? This is like a new space telescope that was getting some publicity for a while there in Chile. Yeah, it's a massive. It's like there's so many big, impressive science things going on right now. Like this is yet another one of them. This is all in Rook. This is all in Kubernetes. Like they're at the telescope. They've got a Josh, do you remember how big it is? Is it a 20 petabyte Rook cluster or a 10 petabyte Rook cluster? I forget. Yeah. Yeah, it's big and it's super high performance and it's awesome. And yeah, this is the kind of scale of what they do. So every night they turn it on and they take like 10 or 20 terabytes of pictures. And so that's like few tens, maybe 60 petabytes over its full like 10-year mission. But like they do a lot of reprocessing of the data in the end, and it's gonna be around 500 petabytes in total. And that gets, just like the stuff at CERN that I worked on, like this gets distributed around the world to tons of universities and I think more than universities in this case as well. Yeah, so there's also like, this slide, I wasn't sure I was going to include this one. It all started, I mean, this was from when I'm speaking to university students. It's like, try to encourage them to try it out at home. Because the only reason I got into this crazy story of going to CERN, honestly, is because I was running the floor's LAN, like SMB server with MP3s back in 1998 at UVic. Like, so I learned how to run a server, learned how to run RAID stuff, worked at the help desk, worked in the physics department, got into supercomputing, then went to CERN and stayed for 15 years and got into all this stuff, helped discover the Higgs Boson, then Ceph and blah, 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 to here I am today. But it's all like, if you want to have that kind of story, and like, just try Proxmox now, actually. Who's heard of Proxmox? Yeah, try this. Behind the scenes at Ceph, that's it, it's in there. I think you can probably also use your local disk, but use Ceph, it's more fun. You can build and like learn those skills that then, that are used in all the big hyperscalers, etc. voila, I think that's, oh, there's one more thing. If you are on our company has this website, analyzer.clyso.com. And if you do try out Ceph, like we have a thing that's just like a fun thing. You can upload something and it'll tell you if it's configured well. We have the same for a Kubernetes cluster. Like if you can upload, there's a tool to like capture some of your configuration. It'll tell you if it's like done safely and the right version and all that. So give that a try. And yeah, thanks a lot. There's a little QR code to our website. That's a picture of me. And that's, if you go to the Rook website, you'll see that like we're like basically one of the only companies doing actual support for this stuff. So, voila. Thanks for listening. Do you want to do
You mentioned that most people are using Ceph through one of these three interfaces, block, object, or file system.
Yeah.
What are some of the things the other people are, how are they using it?
Yeah, good question. So you can use, where is it? Yeah, so there's this thing called librados, and that's just a library that you can bind against. There's Python, Java, is that still a thing? Java bindings, there's bindings in every language, and then you can just use that object store directly. Even on the command line, you can do get and put to it, but it's very slow that way. So you just like connect to a cluster, you can use it. So we have we know of like we have customers that use it directly, like their applications. Let's say like they're like trading firms or something, and they're doing, they just have to do some like ML analytics. They can just like program this and access it directly. They don't need S3 compatibility, because you only need S3 compatibility if you're going to go out on the web, right? Or if you're plugging into something that wants it to speak S3. You only need block storage if it's for VMs, basically. Or CephFS, that's if you're looking to replace home directories or have a Samba share. Like this stuff you can also re-export as Samba, like so CIFS, Microsoft
Samba
compatible.
is in Windows compatibility.
Samba is Windows compatibility, exactly. Yeah. So yeah, exactly. So there's a layer here you can plug in top, and it'll export with make it all for your Windows friends. But yeah, so you can just use that directly. That's just like for extra performance. Yeah, you can go directly to the underlying thing. This is a gateway. This is like a language, like a protocol, and this is basically a protocol with an extra component. But like, if you're just doing object storage, like it's like use it that thing. Yeah.
What about NFS or SSHFS?
Have you heard of Ganesha? So Ganesha is a software, it's a user mode implementation of NFS. So it was the first like PNFS implementation open source. There's a Ceph plugin for Ganesha, so you can do that. So it's like, that's this thing here, CephFS, you can re-export it with Ganesha. But you can also just, you can just mount it. You need a gateway. So you can just mount it and then use like the Linux kernel's NFS server to re-export that mount. That also works, people do that. But with that, it just means that, okay, now you've got like a special gateway somewhere, and if that thing crashes, like, you're down. That's the problem.
What is most frequent failure scenarios for Ceph?
If it's for a well-configured cluster, you mean? Like for something that, if it's configured correctly?
Something in production and like
yeah, so, yeah.
frequently.
Yeah, very good question. These components, this component in the middle is like basically rock solid. The only time that we ever see it fail these days is it's something else. Like that means like hardware or network or something like that. And it doesn't mean like, network is usually like a network misconfiguration thing. Or like, networks get really spooky. At CERN, I always like, we eventually learned, and then I was like, became a bit teasing them. It's like, the best network monitoring that exists in the world is the Ceph cluster, because it finds before any of the alerts go off, like the storage is like not working. So beyond that, like these things, the API, like, so this is POSIX. POSIX is a very, very complex thing to implement. And sure, simple stuff like for me at home or any of us, it's like, it's fine. But if you have like if you have like a batch system with 10,000 clients doing complicated things like parallel IO, and some are opening the files and reading at the same time, there are just like weird locking race conditions that happen sometimes, and that's the kind of thing that impacts. Like in our company, like that's the kind of thing we mostly we need to help people more intensely with. In the cloud native world, it's like this manifests as like just blocked, like PVCs are stuck. And like someone then does cat proc mounts on a host, and there's like 1,000 things there, and it's like, what do I have to do? So they just like actually in that case unpull the plug. It's usually the best. It's weird. On the object side, there are some. So what I'm kind of like getting toward the concept of like it's like software bugs because of API complexity. That's really what it is, and that's what I'm exposed to the most, because it's like, you know, if you're an SRE working in a place, like, okay, you know that the power's down and you did something stupid or whatever. But like when it comes to us, it's because like objects aren't expiring at the right time, or something like, I don't know, I created this, why is it like, why is this not, it's just like, why isn't it working as expected? And it's usually a configuration thing, yeah. But Ceph itself is very, it's designed, I did not at all go into like how that's smart of like where it calculates to put the data and stuff. It has like literally the PhD that got this, that like where Sage Weil, that his project led to this. It's all about creating a language to explain the failure domains in your data center, and to distribute the data flexibly across the failure domains. So things like, all right, the simplest one would be just like, well, put one copy on different hosts. The failure domain is host. Okay, just like replicate it across hosts. But then you can also do things like put the first copy on an NVMe, put the second copy in this room on a spinning disk, and also it's like, but it's rack-wise. And like in this room it's rack-wise, in this room it's like, they make sure they're on different network switches or something like that. So you can just like, it's an infinitely flexible language like that.
So you're talking about a copy on write.
So that's at a different level. Copy on write's at a different level. It's also that, but yes, that's at a different level. No, this is what I'm talking about is like when you're trying to store, like you just want to store your GIF or your MPEG file or whatever, or your file, your database file. Like Ceph needs to store that reliably so that it's going to get your file back when you want it. And to do that, it's like okay, here's how I can say it. You see this? Every single day in this data center, there's probably 10 servers overheating and crashing. There's probably like, I think that, I wouldn't say once a day, maybe, yeah, once a day. This is mostly spinning disk because it's got to be cheap and deep. There's a spinning disk failing every single day, definitely. And you need to make a reliable system out of unreliable parts. That's what Ceph's all about. It's like to the end users, to us when we're using it, we're just like, you know, loading Google Maps out of on our phone or something, or whatever we're doing, loading our Spotify song. Like, we don't notice that actually there's like half the servers are crashed or something like that. It's always just recalculating, moving stuff around and keeping it all reliable. In a way, it's like Kubernetes does, but like it's not like moving servers around. It's just like calculating where the data should be so that you can always read it out. And it does replication for that. That's like RAID mirroring, just like a copy here, a copy here, a copy here, but it also does erasure coding. That's like RAID 5 over the network. But it's not just RAID 5, it's like arbitrary K, M, arbitrary data, arbitrary parity. And yeah, it's like that.
Another question for
Sure.
you. I come from a VMware background.
Yep.
So the storage is traditionally presented in VMware as a SCSI LUN, right? Logical unit number.
Yeah, that's this guy.
That's where that would present as a logical unit number?
Yeah, pretty much, but that's like
The block storage.
But there's exactly. But what it actually is this is actually, it's a very, I mean, okay, I'll tell the answer first and I'll tell the story. It's just that the Linux kernel knows how to do that. This is all built into the Linux kernel, okay? So Linux kernel knows how to mount a SCSI thing, knows how to do iSCSI. Linux kernel also speaks Ceph. You can just say like attach this thing, it's on mount, right? So attach this virtual block device that's out of my Ceph cluster, has this name, and here's my password to access it. And then now you have like /dev/vdb. and you've got your virtual block device, and you can format it with XFS or whatever you want, do whatever you want. Yeah. When we use this, when you use Ceph through Rook, it's doing all of this stuff for you automatically. You don't have to think about it. You just ask for storage, and it like creates the thing for you, partitions it. You have quota or something, formats it, and then you just mount it. And if your host fails, okay, just magically it's all running somewhere else. And like the underlying Ceph cluster was keeping the thing secure, keeping your data secure the whole time. Yeah. The story is that this whole block storage part is an accident. It was like a community contribution in, I think, 2010. Like, this was the focus. Early days before I joined the project, the focus was CephFS. It was meant to be open source, modern, high performance computing, an HPC file system like Lustre. Who's heard of Lustre? Yeah. So Lustre is like an HPC system, and then Ceph was supposed to be like something to replace it, and it does that. But then like, you know, EC2 and AWS came out, and then people started thinking like, wow, I want that also in my data center. So that's where OpenStack came from. NASA and Rackspace made OpenStack, and someone contributed this, like, hey, look, you can just like with your Rados, like here's 1,000 lines of code. Now it can do block devices. It's like, awesome, thanks, Christian. I forgot his name. Yeah. And oh, you got a question?
It seems really impressive to see like how much it can scale. But in 2026, what do you see as being some of the constraints that you're facing in those data centers?
Well, in 2026, everybody can't buy hardware. That's the main constraint. People can't, you can't get block devices. You can't get RAM. That's the thing that we all know, and that's causing major problems for a lot of the. Like, we support commercial enterprise stuff, also research. In the research, it's like a disaster because they have to rescale, rethink their whole like scientific 10-year roadmaps of how much data they're going to be able to store and things like that. So it's a disaster everywhere.
Wondering, aside of supply, from the technology point of view, do you see something where you're actively kind of working on to scale faster?
Well, yeah, there's always, yeah, I mean, when you're working in this business, you understand that, is that mine? No, I don't know if that's mine. Maybe it's mine. Doesn't matter. It's all good. It's a feature. You learn to trust but verify extraordinary claims of like infinite scalability and stuff like that. Like, there's no such thing as infinite scalability. Of course you hit real limits. Some of our, like, some of the work that we are doing now, like Josh and I, it's like to make our largest customer went through the 65 petabyte in one cluster threshold. Was that last year? And that's where we like remembered, oh yeah, shoot, like we forgot there's like a 2 to the power 16 like limit for that constant somewhere. So we had to shift some bits around because like 65536 or whatever was like the limit of like the size of things in one cluster. So we moved it around, and there's like a limit of 10,000 devices. Like, these are kind of like, there are some limits because like you never imagine, wow, 640 kilobytes ought to be enough for everyone. You remember that one? Yeah, that's Bill Gates said that. Yeah, it's just that kind of thing. But there's nothing intrinsically limiting the scalability of it. Yeah.
Thank you.
Yeah.
What is the best practice for deploying Ceph on a bare node Kubernetes cluster?
I would just go to rook.io and follow the docs. Go to rook.io, do it. Yeah, it's all there, it's clear. It should be simple to install. Yeah, and there's a good community there, open source community to help, mailing list. I don't know how they're, I'm more on the, I guess, yeah, I didn't, like, that was another team at CERN doing Kubernetes. They just used our stuff. So I'm not like a super Kubernetes expert. I'm just a user like the rest of us. But I'm sure there's like a community to get started, and the docs are really good, yeah.
One last question for you. When
There's another
You're just one behind, then I'll get you. It's okay, we'll get you.
I have a question for monitoring. As you mentioned that Ceph have intricated algorithms to do smart allocation and recovery. So I'm thinking about it in reverse. Like it can be so smart to tolerate failure, but there will be times that failures in the real system that is out of a threshold. Is there any kind of, because patch partitioning failures are quite complex. You don't know whether it's network failure or node failure, and is there any monitoring tools that is compatible with Ceph and able to do some really deep diagnosis to let people to know that there's a failure out of the threshold there and they need to go on site?
Oh yeah. So thank you for the question. So in the real life, like lived experience of Ceph operators, Ceph itself, like life is really good nowadays compared to when I started for like Ceph itself understanding failures and recovering, and like you don't have to get the sweat coming down your face every day like in the bad days, good old days. But still, there are cases where, hey, it's slow, something's wrong, like this is not, these like different distributed components are not peering with each other, what's going on, it's like difficult to debug, this happens, oh yeah. And that's basically what we do. That's like basically what, at our company, we're just like, we make tools to make it easier to figure this out, and it's not, all of the stuff that's left, like this is a 20 years old open source project, super mature, it's kind of like rock solid. All of the stuff that's left is that very nuanced, subtle, like between the gray areas stuff. It's like, I think once a week we talk with someone that says, hey, do you have the ability to figure out like when an NVMe is just like kind of sick, but it's not dead, but it's not fully alive, it's just a little bit sick. Like that's the hardest thing, honestly. And trust me, we've spent weeks on this problem. It's not, in the end, hey, we're all gonna have jobs, because I think that like, the human element is still quite crucial in figuring this stuff out. Yeah. You had that question, last question, yeah.
Just touching back on you mentioned the thing had a I/O performance of terabyte per second.
Yeah.
What kind of technology, like physical connector technology, was that? I come from a SAN hardware engineering background, so.
Yeah.
We used to connect our NetApp SANs to, using InfiniBand, right?
Yeah.
So
yeah, that's a kind of, like, imagine it's a distributed system, so we're cheating with whatever this number is, of course. We're just
I can't see that running over Ethernet, right? So
it is, but like nowadays you get 100 gig or 200 gig Ethernet to a server. So
gigabits per second. Well, that's you're quoting terabytes per second.
yeah, and I'm imagining that you've got like lots of clients. So this is not in my imagination. I don't remember exactly. Josh, do you remember what the configuration? This was a real thing. This was like one of our customers got a delivery of, I want to say like 500 NVMEs, and this was a couple of years ago. There's a white paper on our website. You can download the thing, get the exact details, and yeah, we used to hand those out too. We could print some more. It's pretty exciting stuff. But it's about 500 NVMEs, and you and like with Ceph, so it's just like many clients reading. This is a read performance number. So many clients reading out those the doing, like, it's kind of like FIO. If you've ever used FIO, that's like a Linux file benchmarking system. Just like streaming out on many clients out from those NVMEs. And we didn't, I said earlier it's like cheating. I mean, in the end, it's like not really cheating because we did it with real stuff with real hardware. But like in a real environment, this was a dedicated reading scenario, right? So you can achieve these kind of numbers. This was a superhero benchmark, right? We tweak everything to get like the number one best performance. Yeah. No, but you can, but like with a real system with enough hardware, this thing just spreads horizontally. There's no central components. So imagine you have 10,000 clients reading out files, streaming stuff, like, just like, it's like, just imagine in the world, in Vancouver right now, I'm sure that we're serving data at more than 1 terabyte per second. Like, so it's just like scaled horizontally across the different buildings and data centers here in the city. So Ceph is like that. You just like, there's no component sharing as long as you got enough.
So you're implying that there's going to be multiple parallel I/O connections?
Absolutely, yes. Many NICs, many servers, many clients. Yes, that's how it all works. Yeah, when I showed this picture here, like these are servers, and this is a small cluster. Well, it's a modest cluster. It's a university lab cluster, and those are servers. Yeah, yeah. For my home lab, I just have one. I just put all these things into one. Yeah.
That being said, I have to add, this is the most amount of questions that I've seen people asking about a project.
Oh, really?
Yeah.
Yeah, that's the thing. I fell in love with Ceph too. It's like it's an amazing project, and it's like such a great community too. So if anyone's interested in this, like, I mean, for sure, subscribe to our LinkedIn, which was there, and like you'll find out because Josh lives. You're in Victoria. We're going to organize a meetup maybe later this year, right? A Ceph meetup, or maybe we'll just.
There's one in Vancouver as well.
We'll do some,
Planning out.
yeah, we're planning it out. So just subscribe and we'll do it. And we're trying to, like, this is the thing, like the community that knows about this kind of software in Europe, it's massive. And I lived in Europe for 15 years, and it's like a very big thing. Here in North America, it's like not the same kind of thing yet, but we want to build that up and get people aware of these open source technologies so that we can all just like level up and work on more interesting applications and stop reinventing this like low level storage stuff again and again and again. Yeah. So just reach out. I think like in the smallest font I could find, there's my email and stuff there, so feel free to reach out. We don't have an office in Vancouver, but maybe soon. We'd like to, if we had a reason to. We've got to get out of the house sometimes, right? But there's
You're a 1 hour flight away, right?
yeah. No, well I'm here in Vancouver. Oh, these things, I told you this is all like made here in Vancouver. These were hand screen printed here in East Van. Like this is all like local stuff. So yeah, you go to the goods on the East Hastings. He's a good guy, my friend Dave. All for you guys. There you go. So thanks.
We also post events on Eventbrite, and we usually have a lot of webinars and stuff. So if anyone is interested, you can just type in our name on Eventbrite, and you'll find all the event information there. Because we usually post all of our Ceph events and everything on Eventbrite. Yeah. So that's a good place that you guys can find us, especially for events.
Yeah. Thanks, Rajali. Yeah.
If you like, just give us all the links. We'll just send it to everyone.
Yeah.
Because a lot of people couldn't come in. I didn't know if you noticed, but the other speaker is still in a traffic jam coming here. And we have like a lot of other people just saying, oh, I don't think we can make it. Like we're trying to get to downtown via our cars, which is, I don't know why people would do that today. But, yeah.
Well, I mean, I guess, so we're wrapping up, but we're not going anywhere, so we can chit chat and I can tell you about the time someone sabotaged the LHC with a bottle of Heineken. But anyway, or other stuff. Yeah, I know, I said it too fast. I can tell you about the time someone sabotaged the Large Hadron Collider with a bottle of Heineken.
Bottle of Heineken?
Yeah.
I would like to know this story.
Yeah, I'm sure that.
Well, this one time, this guy sabotaged the Large Hadron Collider with a bottle of hydrogen. That's the story. I don't know. It's like, yeah, what's even, why did I even say that? It's just like, sometimes, like, people are crazy. Do you guys learn that? I'm learning that recently. But it's like, yeah, it's like something wasn't in a line. Like, it takes like a long time to figure out what's going on. They like someone that was bitter to just put a bottle in the beam line. It's like, that's when they moved out of the way. Okay, it's all working again now. This kind of thing happens all the time and everywhere. Yeah. Yeah. Anyway. Okay. More pizza? Thanks a lot.
Thank you.